I want to talk about power in electric circuits, which power, if you remember, is a really simple idea of work over time. It's that rate of work. Remember our unit for power was the watt. Watt is the unit for power, which is just the joule per second. But in electricity, this work, we don't really care about the actual work. We usually care about the system as a whole. So we're going to talk about voltage. And work is this charge times the voltage. So let's put that in there. Power is charge times voltage over time. How much charge, how much voltage, how much time. And if you look here, well, that's just current. Power is current times the voltage difference. But remember, V equals IR. So I can replace that V with IR. Power is also I squared R. Or I can rearrange this and go, oh, V over R is I. I can replace the I and say, well, power is also V squared over R. 3 different types of powers, depending on the situation. Now, I want to talk about the difference between different kinds of light bulbs. You probably have at least one of these in your home and several others.
Oh, look, an LED light bulb. Ooh, that's bright. It says 11 watts. Oh, look, a CFL light bulb. That's compact fluorescent. Oh my, that's bright. 14 watts, it says. Oh, an incandescent light bulb. Wow, that's just as bright. But this one says 60 watts. And it's really warm.
So if we look at the wattage of these 3 different types of bulbs, we can figure out a lot about them. For instance, we can find the current. I can say power equals I times V. I know the voltage of the house is 120 volts. I can say the current is half an amp. And if I then plug that into V equals IR, I can find the resistance. You can do this for these two as well. Give it a shot. I end up with I is 0.117 amps with a resistance of 1029 ohms. And I end up with I is 0.092 amps with a resistance of 1309 ohms. Something to think about. So what if I'm dealing with a circuit and I double the voltage in that circuit? I take my one AA battery and I put 2 AA batteries in there. What happens? Well, let's look at it. We know P equals IV. That's probably the easiest way to look at this. If I double the voltage, well, okay, it's double the voltage in this situation. But because V equals IR, I also double the current. Bigger voltage, more current. Effectively, I have quadrupled the power. Pretty crazy, huh? We can also look at this in the other equations, though. Well, I have to say, well, V equals I. If I want to look at I squared R, I have to say, oh, V equals IR. I is doubled. But It's squared as well. Same resistance. Same result. Or we can look at V squared over R. This one's probably the easiest. V stays the same. R stays the same. V, we know exactly what happens. We get the exact same result. In the assignment today, I want you to try one on your own. What if we double the resistance but keep the voltage the same? What happens to the power? Give that a shot. The last thing we have to talk about is paying for electricity. You'll actually notice if you look at any electrical bill that you don't pay per current. You don't pay per watt. You pay per something called kilowatt hour. That's using 1 kilowatt of power for 1 hour. Why that? Because it makes more sense in regards to the value we're actually looking at. These are big numbers. 1 kilowatt, it's 1,000 watts for 3,600 seconds, 1 hour. If we actually put that together and figure out how much energy that actually is, it comes to 3.6 million joules. So let's say you have an air conditioner. All right. I looked up one, 11.4 amps at 120 volts. Let's leave it plugged in for 24 hours. How many kilowatt hours of energy does that use? Well, we can say, well, power is just current times voltage. So we can say 11.4 amps times 120 volts. That's 1.370 times 10 to the third watts, 1,368 watts. But for 24 hours, which is 1.368 kilowatts. But for 24 hours, that's 32.83 kilowatts. Kilowatt hours, which is equivalent to 118 million joules. That's a lot of energy. And you generally pay per kilowatt hour. The cost for a kilowatt hour is in the ballpark of about 13 cents, which isn't that big of a deal. It looks like. This air conditioner, only about $4.26 a day. But over the course of a month, you're closing in $127, $130. So that can be kind of expensive.